Recording in progress. Okay, so basically, Euclidean geometry is
This meeting is being recorded.
Is that chapter where you are dealing with finding the angle, knowing like the shapes with parallel lines. You see, that's the chapter.
Okay.
Now, the first basic thing that I would like to plead with you to please memorize this is the properties of the parallelogram. Now, with the parallelogram, both pairs of sides are equal, meaning by so saying, let me try to do this. Yeah, by so saying, I'm trying to say to you, this line, this thing won't draw. Okay, but you can see my cursor. This line is equal to this line, and this line is equal to this line. That means the two pairs of lines are equal, and this pair of lines are equal. Hence, we are saying both pairs of sides are equal in a parallelogram. Got that? And then secondly, both pairs of sides are parallel, meaning this side is parallel to this side, and this side is parallel to that side. From grade 8 up to grade 10, what do you know about the angles that are here between parallel lines with the transversal at the bottom? What do you know about these angles? They add up to
180.
180.
Is it 180?
Yeah, they add up to 108. So it means every time you are dealing with a parallelogram, just know, Ugote, the two angles that are lying on the base of two parallel lines, they are co-interior angles, meaning they add up to 108. Got that?
Okay.
Yeah. And then the most important thing is that the two opposite interior opposite angles of the parallelogram are equal. By so saying, I'm trying to say angle D is equal to angle B. And this angle is also equal to that angle. So that is also an important property to remember, that the two interior opposite angles are equal. These ones. Got that?
A.
And then another thing, the diagonals are lines that are inside these lines from corner to corner.
Which line?
These ones, BD, you see line BD, it crosses with that line again. That line should be line AC. Yeah, those lines are diagonals. Those lines, they bisect each other. So mathematically, Euclidean geometry, when we are saying a line bisects another line, it means more linear a katang line, like let's say this line AC, more katang line BD, a kata into two equal pieces. You understand?
Okay.
Yeah. So I wish I could draw here. I'm struggling, but it's okay. So the diagonals of a parallelogram, they bisect. Understood?
Yes.
Perfect. I'm gonna share with you these slides, so you don't have to do much of note making because you're gonna have these slides. Those are 4 important things I want you to understand as we are about to go deep into this lesson. Both pairs of sides are equal. and then both pairs of sides are parallel, which makes the two angles that are between the pairs of the sides that are parallel to be co-interior angles that add up to 180 degrees. And then the interior opposite angles, for an example, angle D and angle B, they are equal, and that the diagonals of the parallelogram, they bisect each other. Got that?
Okay.
Yes. Let us go to the terminology of circle geometry, because in grade 11, you're going to be introduced to the circle geometry, meaning most of the geometry that you'll be doing for grade 11, it will be the one that is inside the circle. So you need to understand the geometry and the terms of the circle itself. Now, the first thing is an arc. I'm sure an arc, you know it. In this case, an arc can be any portion of the circumference of a circle. That should be off there. Any portion of a circumference of a circle. That's what you call an arc. I've demonstrated it. That's your arc there. And then diameter. I think this is one of the revision words that you may be familiar with. A diameter should, like, it is a line from one point on the circumference to another point on the circumference. But the requirement for that line to be called a diameter, it should be passing through the center.
Okay. Wow.
Yeah. If the line is not passing through the center, the line is not a diameter. That's a very important note you should make. If the line is not passing through the center, the line is not the diameter, until you are told that the line is passing through center. Got that? And then what is the radius? Radius should be any line from center to the circumference of the circle. Look at that. I've demonstrated the radius there on that circle. It's this line coming from center to the point on the circumference. Now the question is, when the line is a circumference, are they all your radius, your radii? Yes. Why? Because the requirement for a line to be called the radius, it should come from the center to the circumference of the circle. Ne?
Well, circumference can try to get that thing like new.
Line na ya circle na. Ine borono ba circle. Bua sotho ke gausi. Borono bo ba circle bo. Wa bona borono bo. Ke yona. Yeah, ke yona circumference into no. Normally we can say it. We measure the perimeter of the circle. Yeah. So what is the chord? I want to use how I defined diameter to make you understand what is a chord. The diameter is any line it will touch one point of the circumference, and then from one point of the circumference to another point of the circumference, and get. But it should pass through the center of the circle. The difference with the chord, a chord is any straight line from one point to another point of the circle that doesn't pass through the center. It like hence on my definition, I'm just defining it as a straight line joining ends of an arc. Because lankanka line mo demonstrating arc, we get a line from here to here. Half a line from one point of the circumference to another point of the circumference without passing through the center. That line is a chord. You get me?
Okay.
So it will confuse if you don't get this. Is you might use a chord as your diameter, because sometimes you chord right placenta. ka hodimo fela kapa ka tlasenyana ho center hanyane fela o bonana hore ke center mo. So you should always read your instruction ko exameng hore the line passes through the center, and that's when you're going to treat the line as your diameter. Without them telling you the line passes through the center, you treat that line as your chord. Understood?
Oh, okay.
Perfect.
Okay. Let me just note it down.
Okay. The line is a chord until you are told it passes through the center. You're gonna treat it as your chord. Tell me when you are done noting that down.
Okay.
Done.
One more second. Okay, good.
Perfect. Now, another important, this one is very much important because costa level 7 the line tangent. I think there are 3 theorems this week in Nalwe. They're related to this line, the tangent. Tangent is not inside the circle. It is never inside the circle. However, it's any straight line from outside the circle that touches the circumference of the circle once. Meaning, respectively, tangent e be line e thetsang circle hangwe fela from the outside. As long as line eno e kena ka hara circle e be thetsa circle habedi, that's not your tangent. The tangent should come from the outside and should touch your circumference of the circle once. That's a requirement to call a line the tangent. Anything besides that, you don't call a tangent. That's also important. You got that?
Yeah, got it.
Now let us recap quickly on the terminology because this is very much critical. We say an arc is a portion of circumference of a circle. Surely you know what an arc is. Please, an arc is not the whole circle. It's just a portion of circumference of a circle. Yeah,
so from any side.
From any side, you have your arc. So we can say the semicircle is a type of an arc, but we're gonna get to that. Mathematicians argue about it, but we're gonna get to it. When only metric, how mathematician, how no arguing. And then the diameter.
I'm not in metric.
Oh, grade 11. Yeah. So yeah, you on the right track because I need to.
I used to.
Yeah, la go take out to laugh. I'm kidding. Yeah. So the diameter, the requirement for a line to be called the diameter, out of the definition that I've given you, the line should pass where?
Through the center of the circle.
Through the center. Yeah, that is very much important. However, it can be any line from any point of the circumference, one point of the circumference to another point of the circumference. However, it should pass through the center of the circle. Now, the radius. The radius is any line from the center of a from the center to the circumference of the circle. So the requirement is it can be any line as long as that line is from the center to the circumference of the circle. Understood?
Okay, so from the center of the diameter up until the circumference. In other words.
Yes, you can. Yeah. But whatever center circle line not necessarily from the center of the diameter, but that is also mathematically correct. But like in this case, diagram so any line to any point of the circumference, you call that a radius.
Oh, so even if it's straight, it's sharp. It's still a radius. It is straight. Like radius and I get a So if like it was straight, ntse le sharp
Eh.
as radius.
In the sharp, yeah.
Sharp.
And then the chord, read the chord in contrast to diameter. A chord does not pass through the center, but it's also a line joining two ends of the arc. It's a line along it touches one point of the circumference and another point of the circumference. But what makes the requirement for a chord? The chord never, and I mean never, passes the center. Got that?
Okay.
Perfect. The tangent, I said this is one of the most important lines you could learn from now until forever. It's a line. This line should come from the outside of the circle. Coming from the outside of the circle, it should only touch the circumference of the circle once. Touch it once.
Okay.
Now, let us move. Monocircle geometry. O tlo etsa di-theorem tse 9. Ha ba ntse ke hopola hantle. Di-theorem tse 9, o tlamehile o tsebe reason ya theorem e nngwe le e nngwe le proof ya theorem e nngwe le e nngwe. But hona le di-proof tse ding tse leng hore they are not for examination purposes. Therefore, ha ke no ruta tsona hore na di-proof-wa jwang. Ne? Mona na re etsetsa fela go pass exam. Well, le knowledge, but knowledge e hlokahalang for your exam. Theorem 1. O itse o kgona ho bona cursor ya ka je? Okay. Theorem 1 is the perpendicular line from center. Perpendicular line from center bisects the chord. In this case, what is your chord?
AB, linear AB.
Yeah, perfect. Because I want to have it center. Now, AB is your chord, and this AB, the perpendicular line, meaning the line that is perpendicular to this chord, coming from center, it will bisect this chord. Can I read what is to bisect? Is to cut into equal halves. Ne? Meaning this theory, it suggests that half a line is center, it takes a chord and a perpendicular to chord. We expect AP to be equal to BP.
Okay.
What are we expecting? AP to be equal to BP.
PB.
Yeah, but we expect until half a line is center and a perpendicular to the chord. That's only when we expect AP to be equal to BP.
Kind of perpendicular again. Perpendicular.
Oh, perpendicular ki like it line if it hits a line and then a form angle 90 degrees.
Also, OP is perpendicular. Kappa.
Yeah, and like the sign of perpendicular, we won't see it angle OPB, we want to into a square mode.
Oh, okay.
That shows perpendicular. I see from the comments. Yes. To bisect is to cut in the middle. Yeah, because when you're cutting in the middle, you're gonna end up having two equal halves. Yeah. So that is all about your theorem 1. But theorem 1 inal the converse it's a page. No, inal the converse. So reading perpendicular line from center bisects the chord. And when we say chord ya rona in this case is line AB, meaning hafela OP ele perpendicular to OB, and OP it was center. Therefore, we are expecting that AP is equal to BP.
BP.
Anton?
Okay. A.
Yes. Let us move. Now, let us prove. Let us prove it. Can you see my now, this peak says you have to draw line. We are constructing. Ne? You see the line, you see line OA into construction line.
A.
And then we're also going to construct line OB, meaning we've joined OA and OB. That is the first thing that we do when we are proving theorem 1. You join OA and OB in a way that you're going to have triangle AOP and BPO. We have two triangles. Outline.
A.
So the first thing that we did was to make two triangles out of out of that, we made two triangles. Now, the second thing that we do, we check, now that we have two triangles, what is it that we are given? The thing that we are given on our drawing is that angle OPB is equal to 90 degrees. Now that angle OPB is equal to 90 degrees, it mathematically makes sense for us to say, therefore, OPA is also equal to 90 degrees. You want to tell us? Yeah, because angles on a straight line, they have to add up to 180 degrees. So if one of those angles is 90 degrees, it means the other angle will be 90 degrees. Got that?
A.
Perfect. Now, we are also given, okay, these two angles are equal. Now let us go to prove our theory. Before proving, let us talk first. Do we agree who OA radius? Like I've defined to you what is a radius. Remember the definition and look at OA.
Radius.
Radius, because it's a line from center to a circumference.
Circumference.
Yeah. And then, do we agree with the OB Leonardo radius?
A.
Perfect. Meaning, if OB le radius, le OA le radius, do we agree with the OA le OB dialga?
A.
You agree with me?
Yes, I do.
And then, do you also agree with the line OP? It's ever as a line for this triangle and also for this triangle. It's a common line for these two triangles. You agree with me?
A.
Meaning, I can say in grade 10 you did congruency. You know the triangular did congruent did the dramas.
Okay, do look at. I do
Yeah.
like again into the other.
Yeah, no. Ka mantswe fela magutshwane ngwanes. Ke di triangle tse tshwanang. Ke ma twins ya di triangle. Di triangle a di le congruent di tshwana ka ntho engwe le nngwe ntle le di label. Yeah. So ha re shebe hore na triangle tse pedi di a qualify ho ba congruent na. The first thing that we've agreed on, the angle OPA is equal to angle OPB. That is given. Right? And then re be re agree ya hore line OP ke line e common for both triangles. Agree.
A.
Ya hao ingetsa ke be wa read ya us.
No, ntse ke ngola, ntse ke re ke A.
Okay.
I understand.
Okay. And then we agree again hore line OA is equal to line OB. And the reason for that is because the two lines are radial. So we're just gonna say radii. So mathematically, harina bo radius or what? Radii double I. Yeah, how na radius is in meti kapas hoing he. Radii. Yeah. Got that.
Okay.
So, harishe, rite side for triangle for triangle tse di le pedi le common ke side and then renale angle and then renale side le. So but the angle there it's 90 degrees. So we can say the qualifier reason it's right angle hypotenuse side. I think it can also be acceptable harigare side angle side. Nzo di upola di reason tsa congruence.
Yeah. I get to one mark. How to go for?
Mudim. Okay. For the triangle di be congruent. Hona le dintho tse leng hore tlamele di tshwane ka tsona, at least di tshwane ka tsona. For example, in this case wa bona re na le di angle di a tshwana le ma side a mabedi a tshwana. So di triangle tseo di tshwana ka angle 1 le ma side a mabedi. Therefore re sentse re dumellana hore di congruent. Ke ntho e sentse tla e le principle from maths e jwang. And then yeah, engwe hape ke hore ma side kaofela a lekane. Then tla be sentse re tseba hore di triangle tse di angle tsa tsona kaofela di a lekana. Wa bona? Le di reason tse ding ke tla o sendela document ya teng. But tlamehile o tsebe fela hore therefore triangle OPA is congruent to triangle OPB. Agreed.
A.
Now that we agree whether the two triangles are congruent, therefore we can conclude by saying, however triangle is congruent, therefore AP is equal to BP, which then take us back to the reason of our theorem, where the perpendicular line from the center bisects the chord. We have proved that the chord is bisected because AP is equal to BP according to our proof. That is how you prove theorem 1.
So conclusion is the perpendicular line bisects the chord.
Perpendicular line from center. That perpendicular line should come from center. Yes. That is your proof for theorem 1. Why boy easy. So tlamehile we tshwarelle tjena of tlhella examine. Yeah. Don't worry. Ntona easy na. Ntho tso tlamehile ngo di prove fela ke radius tsa hao hore ntho tsena ke di radius, di angle tsena di a lekana, line e mahareng e common. Therefore triangle tseo di congruent. Because the triangle is congruent. Yeah. Therefore ma side ana ka fatshe a lekana ana. In this case we have AP and BP. Yeah, you were saying?
For theorem 1, is it always going to be like that for it? Radius, common angle C, and then leave for 90 degrees.
Yes. Prove ya tlo dula le tjena ntho e tlo tjhentjha fela ke di. Ntho e tlo tjhentjha fela ke ntho ke di label. Obviously ba ka nna ba sofe AP le BP go prove hore di a lekana. So how prove a theorem 1? Yeah, how prove a theorem 1? In simple words, ba re fela hore prove hore line AP lekana le line BP. So tsela ya Theorem Two, ke go re provela hore triangle AOP is congruent to triangle BPO. Re provela fela ntwe congruency, and then you conclude with it. Therefore, line AB is equal to BP.
Okay.
Perfect. Are you noting something down, or shall we move?
No. We can move.
Okay. Let me do this. Ne ke batle hore ke o fe quick question mona, but something yesterday ka sa kgone hore ke fumane the question, but I'm gonna WhatsApp it to you, that question, and then you deal with it. It's not a difficult question. Ne ke tlo fa fela 2 minutes or we, but anyways, let us come to the theorem, converse theorem of Theorem 1, the converse of Theorem 1. Now, ntho re qetang ho bua nna le wena ho tswa Theorem 1A, ke hore line ha e le perpendicular from center, e tlo fitla e bisector that chord. Re dumellane ka ntho eo akere? Yeah. Now, hona le ntho engwe hape e leng hore theorem eno e kgona ho etjho. E kgona hore kaucho ha line e tswa center, ke sa bolella hore line e perpendicular, but ke tseba hore line eno e bisector. Okay.
Sorry, like the first sentence. Stuck.
I'm saying, now that we know from Theorem 1A that a line from center, perpendicular line from center, bisect the chord, we can also conclude if ke sa bolella hore line eno e perpendicular, but however ke tseba hore line eo e bisector chord. No tjena case gore ha ka bolella hore line e perpendicular, but ke bolelletse hore line eo e bisector chord, and it's the very same line e tswang center. What am I gonna conclude? Can you make any conclusion out of that?
For the perpendicular.
Exactly. You're gonna conclude that line is therefore perpendicular. Wabo? So how no two no 1 mark. Please keep that 1 mark for the test. But how no, this is a line from center. Hexi. Oh, this line bisects the chord. Therefore, man, this angle is equal to 90 degrees because this line is therefore perpendicular to the chord. Please, dintho tse ke di entseng ka boreti mo. O tsebe hore ke danger. Tlamehile o di ngole di le jwalo fela leqhepeng. O ska ba ingolla tsa hao ne. O ngole sentence ena e le jwalo. Ke dintho tse leng hore tlamehile o di etse tse leng hore bana ba bang ba di etsa ba lo di ngola wa bona. Hore le ske la iphumana le ngwe ntho tse ngata. So tse fapaneng. Line ena e line from center to midpoint. O bo etsa letshwao la perpendicular. Kore ke entse fela ka bokgutshwane. Hore re ske re etsa English e ngata hoba yeah, sekgowa ngwaneso. But line from center to midpoint.
Okay.
So that's of your chord. Okay. The proof for this converse is not for exam purposes. Ke tse ding tsa dintho tse letseng hore dintho tse ding ha ke tlo ruta tsona because ha o tlo di botsa exameng.
Mara kana hle the SBA.
Kana hla kae?
The SBA.
No. O so tla botswa haeba o lo etsa ntho tsa mmetse university kwana kapa kae pejana bophelong ba hao mare selemong sena teng ha o tlo e botswa. It's just not for exam. Yeah, so theorem ena yona tlamehile o dule o tseba fela ha o bona ntho e tje o bolelle. Sometimes ha ba tlo fa line tsena, caution, this is very much important. Sometimes ha ba tlo fa line tsena tse pedi tse drawing ho AP. Wa bona line tse ke tsona no tse o bontshitseng hore AP is equal to BP. Sometimes ba tlo ngola statement ke tse ding tsa dintho tsene ke rata ho di fosa tse. Ha e ngotswe statementing, sometimes ha ba e draw into ba o bontshe di line tse di kwa. Wabo? So ha ba sa no la o kanna e draw o kanna se draw but tlamehile be wena o tseba hore AP is equal to BP. Therefore, angle OPB is equal to 90 degrees. O sharp.
Sharp.
Okay. As I told you, that theorem thing is not for examination purposes. Until 16:45 for minutes because conversing theorem 1. Actually, this is theorem 2. No, it's theorem 1. Conversing. Go for 2 minutes if alone minutes. O bale notes tsa hao hape hobane knowledge ya di-notes tseo tlo e hloka.
Okay.
Sure. Are you ready? Hello.
Yes, I'm
Okay, I
ready.
hope you are refreshed. But mathematically they will make sense. Now, the theorem remember the first theorem in the perpendicular line from center bisects the chord. The second one said to us, yeah, if the line is from center to the midpoint of the chord, therefore that line is perpendicular. Now, this one, you're not here. If line is bisector, like please follow on everything I say. If line a bisector chord, ne? And then that line is perpendicular, but or that line is from center, we can conclude or that line is from center. You get me?
Repeat that.
Okay. Imagine you are not told. Let me take. Okay, I think the slide is okay. Imagine you are not told a certain line is not from center. For an example, imagine you are not told to a line RP passes through center. Why line RP? It's this line.
RP.
Yeah. Imagine you are told to a line you are not told to a line RP passes through center. But however you are told to the line RP is perpendicular to the chord and also it bisects the chord. Imagine, what can you conclude according to the two theorems that you have learned already?
Yeah.
Okay, no problem. Then I give like grade 11 and next now we conclude and the conclusion that you can make, cool. Therefore, linear it was in T. Because remember, in 28 the theorem it's a pedi tse morao e be di nnete kore di line tse o ne di tswa senti. Like for an example, for theorem 1 is the perpendicular line from center bisects the chord, meaning line eno ne ka ba perpendicular go janeng ine sa tswe senti in is now bisect the chord. And then theorem 1b e be re ho rona the bisector from center is perpendicular to the chord. Wabo di le pedi ntse di re from center. Wabo now ye ya boraro e re ho rona dintho tsane tse re ne re bua ka tsona theorem 1 and 2 di teng di le pedi mona. The line is both perpendicular and is bisecting. So therefore we can conclude that line is from center. Am I making sense? Hello?
No.
Let me repeat it. Let me repeat it.
Okay.
Let me take you back to this theorem. Look, you still remember we used the word from center. Like we said, perpendicular line from center bisects the chord. Theorem 1. And then theorem 1b. If line it was center and a bisect the chord, therefore line in and a perpendicular. Now, yeah, theorem 1c yona if line a bisect the chord and a perpendicular, therefore line in it was center. Theorem yona, yeah, ki theorem e re bolellang fela hore does the line come from center? Now this theorem answer the question, yes, the line is from center. Why does it come? Why are you saying it comes from center? Because the line is perpendicular to the chord and it bisects the chord. You see? Yeah. So mathematically it makes sense. Hence, would you like me to repeat or you got it?
I got it.
Thank you. let us move on. Okay, no, before moving on, the reason how ngola exam le test, whether you test their SBA or you test the exam, maybe your teacher might want you to write other reasons, but please get used to these reasons to go fan because the reason is a long NSC examination require. If you don't write these reasons, unfortunately, you won't get a mark.
Yeah, okay.
Yeah, so they are very much important. The reason
In
is
other words,
perpendicular,
okay.
perpendicular
Also,
bisector.
in other words,
Yeah, you can talk.
make it in other words, let me get it clear.
Yeah, but please memorize it, knowing what it makes sense, because you have to memorize it having the foundation. Or the perpendicular bisector, line perpendicular and a bisectant chord. So make sure you are memorizing the reasons with the senseful foundation. Okay. Obviously, the foundation has got to be senseful because it's a whole but to be long ba sensefully ba enlight e-Tutors. So the perpendicular bisector passes through center. So ntitse mantswe a mang hore sekgowa se ska ba stelele and o memorize ntho tsena easy, but this reason is acceptable.
Okay.
Yeah. Will it be difficult for you to memorize? Perpendicular bisector through center, and it makes sense because this line, as I said to you, is perpendicular and it bisects the chord. So the line a bisectum, we call it bisector. That's English. And the line is perpendicular, so it's perpendicular bisector passing through center. You see,
perpendicular bisector passing through center.
Yeah. Meaning ha line is perpendicular and a bisector chord, it means line in a theta through center. With the way I understand until perfect. Let us move. This was so short, I should have added other theorems, but yeah, we're gonna finish all of them this week, hopefully. Now, quick question. We have done all three theorems. I'm giving you 2 minutes. It's 1653, that's 1655. You have to have the value of x. Please find for me the value of x. The value of x. Yeah, find the value of x. Find the value of x. The value of x. Oh, let me share my screen again. Can you see it again? Okay. Can you still see it?
Yo.
Is it tough? I also want to check. Okay. There's information in Excel file number. Sorry. PQ is equal to QR. They are both equal to 4. No, PR is equal to
Wow.
8. Sorry. PR is equal to 8.
PR. Okay, sharp.
Yeah. PR is equal to 8. I'm very sorry about that.
Okay, great. I think
Okay, you've got the answer.
A.
Read out for me step by step how you got to the answer.
Since PR LA 8, which means PQ it about 4, because it's
Perfect.
in the middle. So
What is your reason for that? What is your reason for saying PQ elegantly QR?
It's a bisect. What's a bisect?
Yeah, wa bona ke dinthong tse tjena mo tlamelong le di reason tsa ntse ke di ngotseng ka bokgubedu. Tlamelong le yeah, ke mo tlamelong le sentence ena. Immediately mo concludang hore AP is equal to PB, BP. Tlamelo o ngole ntwena hore because perpendicular line from center bisects the chord. Ke mo ngolang bontho tsena. So that is what -1 mark.
Oh, okay. The chord.
Yeah, go on.
Sharp. And then beginning OP minus PQ is equal to X, since OP is the hypotenuse.
With the fella OP.
OP minus PQ is equal to X.
Okay, congratulations. Maybe your answer is not 3, ne? Yeah. Well, congratulations for understanding me concepting ya Theorem 1. But unfortunately, you didn't get the concept of Theorem of Pythagoras. Don't worry, you will get it because I'm your tutor now. I'm here. Pythagoras said the square of hypotenuse, like OP squared, is equal to OQ squared plus PQ squared. Yeah. Even if it's a mistake, don't worry. I used to make lots of mistakes. And look at me now. I have a level 7 in maths from metric. So it's a mistake now. And I remember I was doing grade 11. This is just because information is still new in your head. But you're gonna get it, believe me. You just need to repeatedly do it. You're gonna get it eventually. So the theorem of Pythagoras says OP squared is equal to OQ squared plus PQ squared. Meaning you don't just sum them, you have to square them. Got it? Perfect. How do you square up? What is your value of X?
I can just let me look. Okay, 5 squared is 25 minus 4 squared 16. Answer is 6.
25 minus 16 is 9.
Or 8
Yeah.
minus keys. And then
And then,
away
yeah. Yeah.
And then which is 3.
Which is 3. So the answer
Oh.
was 3. Ke tla romella le ntho ya teng, le solution ya teng. Perfect.
Okay.
But believe me, what really matter is that you were able to conclude that PQ is equal to QR. And the reason is perpendicular line from center, because it's given OQ is perpendicular to PR. So the reason for that is a perpendicular line from center bisects the chord. Yeah, I'm very much happy you were able to deal with that. Very, very much happy. So the answer is 3. So method wa ya answering o tshwere. Perfect. Now, tsena ke tse ding tse leng hore ke batla o practice ka tsona, and then ke tlo fa le site ke batlang hore o fumane dipotso tse ngata tse tjena hore o ska hlola o etsa diphoso. It was your first time doing this theorem and you got the answer right. So I'm pretty much sure how like that one, you're gonna get more answers right. Possibly body fumana di le right kaofela. And motho a fumane di answer di le right kaofela, o fumane 100%. So you might get 100%. I'm gonna share these slides with you, and then we'll etsa dipotso tsena. Just for time's sake, because now we have 1 hour. Yeah, yeah. Now let us go to Theorem 2, because I want us to do 1 theorem a day. Theorem 2. If we want to simple. In a gigabyte slide, as the concept of subtension. I want us to talk about subtension before going to Theorem 2. What is to subtend? What is to subtend? Ke concept ke batlang hore o tloe ka yona no of calorimetry final examination. O hopola hore o no bolellwe ntho e tjena ke enlight e-Tutors. E re hoe look at BC. Wa bona BC e forma angle O. Wa bona angle O e formuwe ke arc BC.
Arc
Sheba?
BC.
Yeah, o ga dumellana hore BC ke arc. Ya ntsopola re itse arc re itse ke any portion of the circumference, ja? So ga dumellana hore BC ke arc. Tlo re bua hore na what is to subtend? Wa bona BC. Wa bona di line tse tswang BC di fitla di lo forma angle yane ye ho O. Wa di bona line tse di lo forma angle ye ho O. Are you able to see that for real?
I can see it.
Yeah, in that way re BC is subtendile angle O. Wabo? Hello?
Okay.
Yeah. Yeah, and then again, why bona ona le angle 62 degrees hodimo ma? Angle e subtendiwe ke BC. Ho subtenda ke ntho e jwalo fela hore angle e qadile ho tswa pointing tsena tse pedi e bo form ya hodimo ma. That is to subtend. Meaning BC subtendile angle yana 62 degrees, hape subtendile angle O. That is to subtend. Yeah. Besides BC being an arc, how bolele hore ke arc fela kgonang ho subtenda angle. Meaning the straight line. BC ngabe hona le straight line se joineng mona. I wish I was able to draw here. I just don't know why I cannot draw. I don't know why I cannot draw, but I really want to draw, but I cannot. Shame. So BC can be a straight line or it can be an arc, meaning an arc or a straight line, they both can subtend the angle. In that way, how otherwise, angle 62 degrees is subtended by arc BC. Le angle ya O is subtended by arc BC. So subtender, you refer the line from 2 points, be lokopana at that point. So that 2 point, whether it's straight line or arc, is subtended the angle you formula mudimuda. One thought. Yes. So let us see now. Did you get the concept of subtending? Let us take by bona pointy.
I can see it.
And then this other point. You see these 2 points. Now, that's an arc. Just that arc is a label. Arc is subtendile. Is subtendile angle wabona na angle ngotshing 2x2 mo. Meaning ga dumellana hore angle ya x2 is subtendue ke this arc. You agree with me? And then wabona hape o na le angle hodimo mane ya y2. Meaning that y2, how we share by subtendue again? The very same arc, right? Meaning in this case, arc in an subtendile 2 angles. One angle at the center and another one at the circumference. So that is to subtend. I'm teaching you this especially for Theorem 4. I want you to understand the concept of subtension, but we will go deep into subtension. The slidings are or our next lesson. So Theorem 2 yona the angle, like when 2 angles are subtended by the same arc. I just like wabonamo angle is subtended with the same arc, ne? When these 2 angles are subtended by the same arc, and the other one is at center, and the other one is at the circumference, the one that is at center will be twice the angle at the circumference. Meaning, haibaning centimo angle 60. It means respect lower money circumference. Let me repeat that. Haibaning the angle, this subtended by the same arc. One of those angles is center and another one is on the circumference. We are expecting that the angle at center is twice the angle at the circumference. By so saying, if the angle at center is 60 degrees, we are expecting that the angle at the circumference is half of 60, which is 30 degrees. Understood? So Theorem 2 ikatla ka mefuta e meraro. A je wa bona mo ba ntse ntho ya zigzag. Ha ne kena sekolo ne ke bitsa zigzag ntwena. Ke picture 1. Ke tsela ya pele ba ka botsang Theorem 2 ka yo. Tsela ya bobedi ke ntho ene ntseng something like ntho e jwalo yona ntse le the same thing. Wa bona ntse le arc e subtendile x1 le y1. Wa bona arc e ke buang ka. No, this arc. Sheba x1 in a subtendue again. Wa bona x1 is subtendue. X1.
Oh, excuse me, I'm looking at
sorry. X1. Wa bona x1 is subtendue again. That arc. Yeah. Now, the very same arc wa bona if it is subtend down with you.
Y1.
Now, they are both subtended by this arc, as you can see.
Okay.
Can you see that? Now,
I can see.
because they are also subtended by the same arc, and the other one is at center,
Oh,
and the other one is at
step.
sure.
I really have to go to make it on my.
Oh, ish, no problem. Because our class is even finished. I took too long. I will make sure that on our next class, I go through the proof of two and also finish my explanation for Theorem 2. However, it was nice teaching you. You are a very responsive person, which is what I prefer. Everyone watching us live, please join us. Join us to get more of these lessons. Life Sciences, grade 12, Mathematics, grade 11, you find me. Out of 7 subjects, you find other tutors like me, like e-Tutors. Thank you so much, Mohomosi. You can leave the class.
Okay, thank you.
Thank you.